So we're going to start cycle 4. In cycle 4, we're going to have quadratic transformations, and I'm making this video because if some of you missed the class, you can come over to this video and watch it and fill up your notes, because we're going to have a different approach for this cycle. So we're going to name this one the control. And for this section, we're going to have quadratic transformations and graphing. So we know that in a quadratic function, we are done with linear functions. So now in a quadratic functions, the greatest exponent is 2, as we can see it here. This is a quadratic function because my greatest exponent is 2. In this case, you're going to see an exponent 2. I have exponent 2 here. I have an exponent 2. And I'm going to keep an eye on that one. So my graph is going to change a little bit. It's not a straight line. It's going to be a parabola. We're going to graph one in a minute. These functions can have a quadratic term, a linear term, and a constant term. So in this case, we have here the standard form of a quadratic function. And this term here is the quadratic term. I'm going to QT. This one here is the linear term, and this C is the constant term. It's a number. 1, 2, 3, 4, 5, 6, 7. We're going to add, if we have a quadratic function, A cannot be 0. A cannot be 0. Okay, so the graph of a quadratic function is called a parabola. So for example, I have this table. This table represents the points of the parabola. So we are going to graph a parent function. So what is a parent function? The parent function is a function in its most basic form. So in this case, for example, for this parabola, the most basic form, we're going to follow this number. For example, 0, when x is 0, y is 0. So I'm going to start with this point here, 0, 0. And then I have 1, 1. When x is 1, y is 1. When x is 2, y is 4. See, here's the point. When x is 3, y is 9. I cannot keep going the other way. Parabola is a function that reflects in the y-axis if it's a parent function. So I just need to match this number on the left side of the y-axis. So I have 1 unit to the right, so 1 unit to the left. See, 1, 2. So 1, 2 here. How many? 1, 2, 3. 1, 2, 3. And then I just graph this parabola. And this is what we call a parent function. This is going to be the parent function. I cannot keep graphing the next point because I don't have a space. So something that is going to help us to ease the graphing of a parabola is the rate of change. This is a rate of change that we use sometimes to graph a parabola. For example, how this works. I have 1, 3, 5, 7, 9, 11, 13, and 15. You're going to learn to use it if you want. For example, I'm going to start in 1. This is 0, 0. So this means you're going 1 unit up and 1 unit to the right. So this point. Then you're going 3 units up. So from 1 now, 1, 2, 3, and 2 units to the right. So you add 1 unit to the right. And then from this point, we're going to do 5. So 1, 2, 3, 4, 5. And then we add 1 more to the right. 1, 2, 3. See? The same points. So if you don't have a table, we're going to use this rate of change. Usually we're going to use the first 3 numbers because that's where my grid is going to have a space for. Okay, now we need to understand that the rate of change is not a slope. We're going to explain what the slope is, but it's not a slope. Now, next, we have a vertex form and we have a standard form. At this point, at the beginning of this class, we are going to use the vertex form. Okay, so in the vertex form, in this case, we have the value of a, x minus h to the second power plus k. And the standard form we mentioned is y equals ax squared plus bx plus c. A in both forms is the rate. That's going to be the rate. That's going to tell you how the graph is going to be growing. It makes the parabola wider or narrower. And I'll explain that one in a minute. The graph in vertex form use transformations to find vertex. Use your rate to get other points. Okay, so we're going to use transformations to find the vertex. The graph in a standard form, find the axis of symmetry. These are words that we're going to be using, axis of symmetry, and find vertex. Use your rate to get the other points. Now, on a graph, vertex point in the center of the parabola. Each vertex is either a maximum or minimum. How can that happen? If we graph a parabola, for example, this one, this graph is y equal x squared. See this point here? This point is called a minimum. Minimum because the parabola is coming down from the left. From the left is coming down and then turns around at this point and then start going up. So this point is a minimum. These points above the zero, they are greater than, so it's a minimum. If the parabola is negative, for example, negative x squared, then my graph is going to be in the opposite way. It's going to reflect in the x-axis. See? So now instead of having a minimum value, I have a maximum value. It's the top value, the highest point. Is, for example, if you have seen a baseball game, when someone hits the ball goes and form a parabola. When the ball starts going down, that's your maximum value. We're going to see some applications of these cases. Each vertex is either a maximum or minimum. So if we have a parabola opens up, it's a minimum. If we have a parabola that opens up, opens down and opens up, this is down, then this is a max value. Max minimum value is the y coordinate of the vertex. Remember that in your vertex, and we're going to have some examples later, we have h comma k. So it's your y value of your vertex. The minimum or max value is the y coordinate of the vertex. What is the axis of symmetry? Is the vertical line through the vertex. Is the vertical line through the vertex. For example, if I have this parabola here, I'm going to draw a parabola, and it turns out it goes this way. Okay, we know we're going to have a line, imaginary line. This point is my minimum point. That's where the parabola turns. And this line where the graph is going down and then switches directions is called the axis of symmetry. Axis of symmetry. Okay. In this case, the axis of symmetry is the y-axis. See, that's where the graph turns around. So the y-axis is the axis of symmetry. Double M. Roots, zeros, and solutions. The x-intercepts where the graph crosses the x-axis. In this case, it doesn't cross, it touches the x-axis. It touches the x-axis, then turns around. This is the x-intercept. And is also this y-intercept because it crosses the y-axis at this same point. In this case, this one here we have 1 and 2 x-intercepts because the parabola touches and crosses 2 times the x-axis. As we can see, this one keeps growing this way, so at some point here we are going to have the y-intercept, but we are going to learn how to calculate that one later. Now what we have, y-intercept is where the graph crosses the x-axis. Domain, all the values in x. The domain are all your values in x. The range are all the y values. Now, where are we going to start? We're going to start from the negative to the positive. This is the x-axis. This is the y-axis. So we always going to start from negative to positive, negative to positive. Now here, this is your x-axis, y-axis, x-axis, y-axis. So we are going to calculate the domain and range. For example, here, domain are all the x values. Y, look at this parabola. It's coming here, turns around, and keep going. It extends to negative infinity and positive infinity. It's constant, never stops, keeps growing, 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 growing. So the domain is from negative infinity to positive infinity. That means never stop decreasing from the left. It's coming down this way. If we extend, it keeps coming, and then it keeps growing that way. So it's from negative infinity or positive to positive infinity. Now, another way is saying all real numbers. What is the range? The range is different. Okay, the range is different. We mentioned that the range is going to start at the point in the y-axis. In this case, I have -2, -4, so this one is -3. So my range starts at -3 here, because I'm coming from negative infinity. I'm coming from the negative numbers, -7, -6, -5. There is no graph here, so the graph starts here at -3 and goes, as you can see, all the way up to the positive infinity. So positive infinity. That means that graph keeps growing, 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 growing up without stopping. Let's do the problem number 2. Domain. Again, the domain is always going to be the same, from negative infinity to positive infinity. That's the domain of a polynomial function, from negative infinity to positive infinity. Or you can use all real numbers. It depends what Alex is asking you to do. Let me do the domain of number 3. Again, from negative infinity to positive infinity. And this we use parentheses because it's coming indefinitely from negative. We don't have a starting point and we don't have an end point. So that's the reason why we use parentheses. Now look at the range in this one. The graph is coming from negative infinity and it stops at 1 here in y. It stops at 1, and I'm going to close because it goes to 1, hits 1, and then turns around down. So that dot is closed right here at 1. Same here. The graph, there is no graph in this area, so the graph starts at -5 here, -5, and goes to positive infinity because it grows all the way to positive infinity. So that's going to be how you're going to calculate the domain and range. Okay, vertex form, we're going to have the vertex h, k. Okay, k is always going to have its sign. Sign's never going to change. If this number is positive, the value of k is positive. If this number is negative, this number is going to be negative. The sign remains the same. Now, the tricky part is the x value. See, inside the parentheses, you're going to make x minus h equals to 0. Solve for x. So x is equals to h. That reason why I've been mentioning you that the value of h is the opposite sign of the number that is inside that parenthesis next to the x. And standard form is trickier to get the vertex. It's not impossible. We're going to see it. But in this case, we're just going to need the intercept is the constant number. C is going to be your y-intercept of this function, of the standard form. Okay. Let's turn around. We have some problems. We have the vertex form. of your parabola. Now I need to explain something. Remember, in transformations, okay, in transformation, if you have a horizontal translation, that means it moves to the left or to the right. It's horizontal, it's the horizon, it's the flat surface. If my h is negative, it moves to the opposite side of that sign. Instead of moving to the left, it moves to the right. Remember what we mentioned? If you have x minus h equals to 0, x is equals to h. So it moves to the positive side. So, and if h is positive, it moves to the other side, to the negative, because x plus h is equals to 0. If you move h to the right side, x is equals to negative h. So in this case, we're going to move minus h units. Now, you have your function x, and then you have the independent term plus k. That means the graph is moving up. If you have minus k, the graph is going down in the y axis. That reason why it's called vertical translation, moving up or down in the y axis. Now, reflection. What is reflection? When you have a negative function, so it reflects in the x axis. So this is positive, and if you have a negative fx, that means that graph is going to reflect in the x axis to negative fx. Then here, vertical stretch or compression, we're going to see it more closely, because if the value of a, for example, when you have y equals to ax minus h squared plus k, if the value of this number is greater than 1, not equal, greater than 1, that means 2, 3, 4, or 5, then you're going to have a vertical stretch. That means it's going to be narrow. It's going to narrow the graph. The vertical stretch is going to be narrower. And then if you have a number between 0 and 1, it's going to compress, or you're going to have it wider. You're going to have a wider graph. We're going to see that one in a minute when we do the example. So now we're going to start with problems. Examples. So vertex from quadratics, we have the vertex form. We know that h, comma k is your vertex, so we're going to start from that point. So for example, I have x plus 3 to the second power, x plus 3 to the second power. What I'm missing k. If I'm missing k, is same way I don't have money. That means it's 0. So I have plus 0. So the vertex in this case is negative 3, comma 0. Now remember, if you get confused here, just take this x plus 3 equals to 0, and you have x is equals to negative 3. It's the opposite of this number. What is the transformation in this case? See this one, you have x plus 3. This is 0. That means the graph doesn't go up, doesn't go down, remains in the x-axis. But we have the value of h is negative 3. That means it's moving left 3 units. So it goes from, this is 0, 1, negative 2, negative 3. This is my vertex. This is my vertex. Remember the rate? The rate, I have 1, 3, and 5. So I'm going to do, this is 0. Start from negative 3. I go up 1, right 1. Up 1, left 1. Then I have 3. So from this point that I left here, the 1, 1, 2, 3, 1, 2. 1, 2. Then I have 5. Do I have 5? 1, 2, 3. I don't have 5. And then I just graph my function. That's my parabola. That's the first graph using the rate. If you want, you can make a table of values, x, y. Looking at your vertex, you have -3, so you have -3. You know you're going to get 0 in the y value because -3 plus 3 is 0. 0 to the second power is 0. Plus 0 is 0. And then you can do -2. Okay. -2 plus 3 is 1. 1 to the second power is 1. See, it's exactly the same as the rate. If you know how to use the rate, everything is going to get easier. Now, let's move to number 4. I have y equals x squared minus 4. Now, what is the difference from this form? The x is a square. There is no parenthesis. Okay, there is no x minus h. That means this form is the same as having y equals x minus or plus, let me put plus 0 to the second power minus 4. So my vertex is 0, -4. We mentioned before that this -4 remains the same. This number remains the same, so it's 0, -4. What is the transformation? In this case is down 4 units. So that means 0, -1, -2, -3, -4. And now I use the rate of change, the rate 1, 3, and 5. So look at this one. I go up 1, right 1. Up 1, left 1. Then 3. From this point, don't start from -4. Start from -3. 1, 2, 3. 1, 2. 1, 2. Okay. Then I go 5. From this point here where I left, 1, 2, 3, 4, 5. 1, 2, 3. And then 1, 2, 3. And then you graph. And that's your problem. We go now to problem C. I have y equals -2, x minus 1 to the second power. I'm going to add plus 0. Now my value of a is changing. I don't have 1 anymore. So I have -2. If I have -2, look at this one. Let's do the vertex first. The vertex is 1. Remember, x minus 1 equals to 0. Solve for x. X equals to 1. 1, 0. So let's do the vertex. This is 1 in x, 0 in y. Transformation. Number 1. The function is negative. So this is a reflection on x-axis. Okay. Number 2. This function is right 1 unit. Okay. Right because the function moved 1 unit to the right. And finally, because we have these 2, okay, remember this one. If the value of a is greater than 1, we're going to have a vertical stretch or narrow. So in this case, we're going to have a stretch of 2. Now, we need to be careful with the rate, because we usually use 1, 3, and 5. But now we have this rate here, this -2. So what we're going to do is just multiply by that 2. So 1 times 2 is 2, 3 times 2 is 6, 5 times 2 is 10. Let's do it. So we start here. Instead of going up, we're going down because it's negative. We have a reflection in x-axis. This is x. So we are going 2 units down, 1, 2, and then 1 left and 1 right. Same rate, okay? We're going down and 1 to the right, 1 to the left. Now we're going 6 from this point. 1, 2, 3, 4, 5, 6. I'm going to do it here. Then 1, 2, negative 1, negative 2. Wait, negative 1, negative 2. Yes, this one. And then just graph. And that's our function. Okay. We're going to the next problem. So I have y equals 1/2 x squared plus 2. Let me transform this one as 1/2 x plus 0 to the second power plus 2. So my vertex is 0, 2. Transformation. What happens? That graph is going 2 units up. Okay, I'm going to start with that one. Up 2 units. Up 2 units. Okay, number 1. Then I have, in this case, if the value of a is between 0 and 1, 0 and 1, that means a fraction. Is between that in proper fraction 0 and 1. That means we have a vertical compression of the graph. We're going to have a wide. So I have compression by a factor of 1/2. Of 1/2. Now the rate. What happens to the rate? So I have 1, 3, and 5. So I have times 1/2 times 1/2 times 1/2. And this one will be 1/2, 3/2, and 5/2. Which is, if you do decimal, 0.5. This one is 1.5. And this one is 2.5. You can do it with the calculator. 5 divided by 2, 2.5. Or I usually think half is just like half of a dollar, 50 cents. 3/2 is like $3 divided into 2 people is $1.5 each. Usually when the students think about money, it's easier for them. So let's start. The vertex is 0 and 2. So I have 0, 1, 2. We are going to start here. The parabola in this case, okay, remember that is not negative. My rate is not negative, so opens up. That means we're going up. But my rate in this case is 1/2. So instead of going a whole unit, I'm going half unit. And then 1 to the right, 1 to the left. This is trickier. This one will be better with a table of value, doing the x and y. We're going to do one in the classroom. Now I go 1.5. So be careful because now this is 0.5. This is 1 unit, 1.5. 2 to the right and 2 to the left. Okay. From this point, 2.5. So remember, this is half, 1. Then we have 2.5, then 3 to the right, then 3 to the left. And see how this graph is getting wider. And that's my parabola. Okay. Now we have on your own, you're going to solve these problems on your own. You're going to have time to solve these problems. But I'm going to, if you want, you can just pause the video, give it a try, and then play the video again. But I'm going to solve this one. What is the vertex? 3 and 2. 3, 2. Now, what's happened? Transformations. This is my vertex, 3 and 2. 3 in x, 1, 2 in y. This graph is moving right 3 units, up 2 units. Then I have a reflection in the x-axis because it's negative, so instead of going up, it's going down. Okay, reflection and that's it, because I don't have a rate here, so there is no wider or narrow, so my rate is 1, 3, and 5. So let's start from this point. So instead of going up, we're going down. So I have 1 to the right, 1 to the left. From this point, 3, 1, 2, 3, 2 to the right, 1, 2 to the left. Then I go 5, 1, 2, 3, 4, 5, 1, 2, 3. Then same. I need to make sure I'm in the center. 1, 2, 3. So this graph goes down. This parabola goes down. I have a max value. I'm just adding that one there. Now I go here. This number is positive, so my vertex is -1, comma, -3. Now transformation. Now I have this 1/2 here, so it's between 0 and 1, so I have a vertical compression. So in this case, I go to the left 1 unit, to the left, okay, 1 unit to the left. Then I have, in this case, down 3 units, compression, by a factor of 1/2, and I think that's it. That's it. So remember the rate in this case: 1, 3, and 5. So let's start with the vertex. -1 and -3. -1 in x, then 1, 2, 3. These ones we're going to multiply by 1/2 times 1/2 times 1/2 times 1/2. So it's 0.5, 1.5, and 2.5. So I go up 0.5 units, right 1, left 1. Then I go 1.5, so 0.5, 1, 2 units, then 2 units. Then I have 2.5. So I start with this one. So I have 1, 2.5, 3. Then we count again here. Then 1, 2, 3. This one. Then here, 1, 2, 3. Here. That's enough points. If you want to do another one, in this case you can do 7. Remember that the next rate of change is 7, so it's 7 over 2. So here in this case you can have 7 times 1/2 is 3.5, and I'm going to start here. This 3.5, 0.5, 1, 2, 3, 1, 2, 3, 4. Okay, 1, 2, 3, 4. So you got more points, and then you just get those dots together, and you're going to have your graph for your problems. So if you have any questions, please do not hesitate to let me know. We're going over this one in class. So I hope you have a wonderful day.